Okay, so today we will try to solve one linear regression problem, and this is a problem that I have picked up from one of the university question, and the question says that you have to first plot it mathematically and then solve it mathematically and plot it later on either on R or in SPSS. So we'll use R here. So let me show you the question. The question says, just 1 minute. Okay, it's a very simple question that says the corresponding heights of sons and daughters along with the father are given below in inches. So you have a variable, three variables x, y, and z. One of the variable is a independent variable, the height of father, and you have the dependent variables as height of sons and heights of daughters in inches. The question says, number one, find the height of son when the height of father is 68.5 inches. So we'll plot a regression line and then we'll try to find out. And also it says that in the plot, so that the mean of father and sons intersect on the linear regression line. So this is one of the property of regression line. So we will plot it in R and C, and the final question says that plot the regression lines of father and sons and father and daughters. So basically plot both the regression lines. That's what the question says. Now we will use this basic method when while solving this mathematically. The correlation coefficient is number of times of the observations and into summation of x multiplied by y minus summation of x into summation of y completely whole divided by square root of n into summation of x square minus summation of x whole square, this multiplied by n into summation of y square minus summation of y square whole square. So this is one of the derived formula from correlation coefficient. Do not get overwhelmed with this formula. You can just refer any statistics document or book and you will get this formula. Out of the various formulas for coefficient of statistics, coefficient of correlation, this is one of the formula that you can find out. The reason why we have taken this particular formula is because we know the values of x and y, and this is and we know the value of n because we have n variables, 8 variables here. So n is equal to 8 in our example in total number of observations. And one assumption is when I write summation of x, it implies is equal to y is equal to summation of from y to n xi, right? So when I write summation of x, it means summation of all the x variables. Okay, so this is a very basic formula, and I'm sure you have the necessary background to do this. This is for the correlation. Now for the regression or the line of regression, now we can use again this formula once again. This is again a very elementary formula and nothing to be overwhelmed with this. So this is y minus y bar is equal to the correlation coefficient which we derived in the previous slide into the standard deviation of y divided by standard deviation of x and whole multiplied by x minus x bar, right? So with this particular formula, we will derive the slope and the intercept, slope which is referenced as b in R, and intercept which is referenced as a in R. So it says y is equal to bx plus a. So this is the intercept and this is the slope. If you have to find out the regression of x on y, you just have to swipe the values of y with x accordingly. So we are not going into the mathematical details, but I have found out the value in the regression line using this equation. My final value, just to show you, is this. Y is 1.14x. This is the final line. Y is equal to 1.14x minus 7.76. So this is the linear regression equation that I have derived from the given data. Here 1.14 is the slope and minus 7.76 is the intercept. Okay, fine. So this is the mathematical part of it. We will now go to the R Studio and we'll try to plot the same in R. Here if you see, I have taken two libraries, ggplot2 and the tidyverse. Tidyverse is not the requirement of this particular problem. The reason I have taken is I just want to show you the last part of the solution using a tibble. If I use a tibble, then tibble is again it is like a data frame, but there are a lot of different features in tibble, and you can just search the manual and find out. So if you are using tibble, you need tidyverse and or tibble library, and for qplot we need ggplot. That's fine. So what I have done is I have taken three vectors x, y and z, so each representing the height of fathers, height of sons and height of daughters in inches. So the values inside the x vector represents the xi variables, y represents the yi and z represents the zi. And if you remember from our pen and paper solution, this is what we got. No, this is not the one that we got, sorry. This is what we got, 1.14 as the slope and minus 7.76 as the intercept. So let us first try to plot the solution which we have derived using pen and paper. So we will try to plot this solution, which is definitely not the aim of this video, but I'll just show you. So this is this is the linear regression line which we have derived using the pen and paper formula. The problem with this is in the real world you will not be given just 8 or 10 data points. The vectors will be huge with several thousands or millions of data points or variables inside, and solving it mathematically is not possible. So we will discard this option and I will show you a better way of doing it in R. So the way we do it is with these y is here the height of sons and x is the height of fathers. So we'll use the LM function y tilde x. This will give the equivalent linear equation of y on x. So if you run this, we get the same values of intercept and slope. This is the intercept and this is the slope, which we have earlier derived using the pen and paper method, which is a tedious method, right? So R derives the intercepts and slope. So we'll straight away go and plot this in R and see how it works. Now these are the real data points. Don't get afraid by seeing this plot. We will use a function called abline. This is a function abline where I'm using the two parameters, one as an intercept and the second parameter the slope, and this will create the regression line. This is what we wanted as per the question. The question says plot the linear regression line using R, and this is what is the linear regression line. X is the height of father's height and y is the son's height, and basically y axis is a dependent variable. Fine. So we have done the second part. The third part says so that the mean of the father and the mean of the son intersects, they will intersect on the regression line. So the mean of son is the mean of this y axis. It's not the axis but the variables on the y axis, and the father is on the variable on the x axis. So the mean of y will be a vertical line and the mean of x will be a vertical line, mean of y will be a horizontal line. So accordingly I have taken this. So if you see this, let me run one by one so it will be clear to you. You see this mean of y, so this is the mean of the son, and the second we will run as mean of the father, and both intersects on the line of regression or linear line of regression. So we have done the third part as well, but if you remember, there was a question where it says find the value of the son's height, which is on y axis, for a value of 68.5 on the x axis. When father's height is 68.5, what is the value of the son? So we can just run it abline vertical line 68.5 and we can see fine. So this is father's height 68.5. it is intersecting the regression line at this point, but how do we find out the corresponding value on the y axis? There are various methods. You can find it programmatically, you can use intercept or intersection or even predict various other methods, but we are not going into those programs. Programmatically we are not going to solve it because we just have to find one value. We can use the locator function here. If you see, this is a locator function. Just run the locator function, then you will see on the plot that locator is active. It says locator is active on the top left side of the plot, and escape to finish. So you bring your cursor near the point of or on the point of intersection, left click, drag it to the left corner, press escape, and probably I have not done it properly. So this should give you the corresponding value of, say, 65.45. the corresponding value of y is 73.2. so it depends on how accurate you click at that point, it will give you corresponding value on the y-axis. So if the father's height is 65.45615, the son's height is 73.20169. Now once again, if I do it, let me try to improve it. It depends on your skill, how best you do it. Now 65.20, this is not accurate because the question was 68.5, so it's not the right, no, this is not right, this is definitely not correct. I go it and drag it here. This is the correct, I'm sorry, the previous one was not right, so this is the correct one. So for a value of x 68.5, the father's height is 70.2483. For a value of 65.13, the father's value is 73. So basically this is what it shows. Anyway, so we have done all the three parts of the question. The final part of the question says that you use qplot to, or you plot the regression line of daughter on father and son on father. This is on son on father, so we can similarly do daughter on father, but I just want to show you one more thing here. So this is the one which we have done so far. I mean, this particular thing, we have taken father's height as a dependent variable and son's height as an independent variable, because this is what the question has asked. But if the question says the reverse, now if father's height is the dependent and son's the independent, then you have to be sure that you have to swap the x-axis and y-axis accordingly. Now this is not in the question, but assuming we have to make the father's height as the dependent variable, and this is how we can do it. You see the x lab, the label on the x-axis is now son's height, and the label on y-axis is father's height, and then you get a lm x tilde y. Previously we have done lm y tilde x, so this is lm, this is not in the question, but just to remember, we can draw this as well. Let us see how this curve looks like. Now this is what is the first one, then I do lm x tilde y, and I get these. Okay, what is the value it comes? So intercept is 40.8968 and slope is 0.3875. Fine. So I give these AB line, and this is the regression line for the swapping of the y and x axis. And if I have to find the mean, once again the same thing, I mean it is same, so the means of x and y intersect the regression line. Fine. So we have now done the plotting of all possibilities of the first part. Of course this was optional. Now the second part, we have to plot the regression line of y on x and z on x. Z is the height of the daughter. So far we have not used the daughters, so for this I have used a table. It's not mandatory, you can use it either using data frame or any other method you want, but I have used table just to show you how it looks like. So for table, you can either include this library tdverse, or you can include the library, the smaller library. If you want, you can include table, so whichever way you find it comfortable. I have the whole package of tdverse, so I prefer that. Now if you see the last part, this, let me remove this plot. Okay, so this is lm yx, we have done it already. On the daughters, on father, lm z tilde x, so this is the value that we get. So this is the for the son, and this is for the daughters on X. So son and daughters are now dependent variable on father, and this is the way we create a tibble. I've used the tribble function to create it. So this is a very simple syntax. You can always look, I don't, if you are not clear about this syntax, go through the documentation and you can always have a look. So this is the int slope is the tibble name, something similar to what we do in a data frame, and I'm using a tribble function here. These are the names of the columns and these are the names of the row entries. So let us run this and see what happens here. So if you see, don't worry about the warnings that we are getting. I will try to now print the tibble that 1 minute that we have created. So this is the tibble that we have created. A tibble is it's a 2 by 3 tibble, and we have the 3 column names: header, intercept and slope. The header is character and the intercept and slopes are doubles. So this is what we have done it. This is the one way of plotting qplot using tibble. It's not compulsory that you have to do it this way. If you have any other simpler way, you can use it. Now in this ggplot, if you see, I have given the data as the tibble, and similar to abline, we are using geom abline in ggplot, and the aesthetics we are setting to the intercept values and the slope values, and the colors we are setting to the factor of the header, because we want to see, because this is a character and we want to convert it into a categorical variable or the factor variable, and then we want to distinguish the colors of these two lines, the regression coefficient of a daughter on father and son on father. So son and father, we have already done it last time, so this time we are combining, and x limit and y limit is the limits of the x and y axis. The reason I have taken 60 to 100 is because all our data values are between these 60 and 100 limit. So we run it, and you can see this graph. So the one which is red is the one of regression of y on x, the son on father. The one on blue is the one regression of daughter on father, and this is what was the final part of the question. So we have solved all these 3 parts of the questions that we had. You see if there is anything left in the questions. Okay, so these are the 3 things that 4 things that they wanted. Height of the son, where father's height is 68.5 inches. We have done plot in R, show that the mean of the father and sons intersect on the linear regression line, and plot the regression lines of father and sons and father and daughters. So we have solved this question. I hope you like this video. Thanks for watching, and keep watching my future videos as well. Thank you. Bye.